Hi, in this video we are going to work on the perimeter and the area of sectors. So basically a sector is a fraction of a circle, like a slice of a pizza. So if I get rid of this bit of the circle, I have a pizza slice, right? So this is called as the sector. Okay, so it's a fraction of a circle. Now, for a sector, I can calculate two things. One, the arc length, because this is an arc here, all right, this is an arc, and I can calculate the arc length, and also I can calculate the area of the sector. All right, so first let's start with the arc length. Right, now because this is a fraction of a circle, right, we need a fraction to go on. We can get that fraction from this angle. So if I call this angle as alpha, all right, and we know that in a full circle, right, if I have the radius here, right, in a full circle, the angle here is 360 degrees. So I'm going to compare this angle alpha here with the full circular angle, which is 360 degrees. So basically, what I'm going to write down is alpha over 360 to describe the fraction of this circle. Now, for the arc length, I'm going to use this with the circumference. So it's going to be times 2 pi r. This is going to be my arc length, right? Which is this length, right? This is not the full circumference, it's just this bit, whatever that angle is, of the circumference. So basically, I'm calculating a fraction of the circumference. So if the arc length formula is this, then now I can calculate the arc length. Say, let's say this is 60 degrees, right? And the radius will be 4 centimeters. So if we go with these numbers where I substitute here, right, I'm going to have 60 over 360, right, times 2 times pi times 4 as the radius. So if I calculate this, I'm going to find the arc length, the length of this curve, right? So if I do the calculation, I can write all this into my calculator and get 4.1887, and it goes on like that, of course. If I write this to 3 significant figures, it's going to be approximately 4.19 centimeters. So this is how I find the arc length. I use this fraction, which is this angle given compared to the full circle, which is 360, multiplied by the circumference, right? So this is how I find the arc length. Now let's look at this example. It says find the perimeter of the sector below. So we're talking about this bit, and I'm going to find the perimeter, meaning I'm going to find the arc length and I'm going to add the radius. And I'm going to do this twice, because if I start walking from here with a full round, I'm going to end up the same point by going through the arc length and 2 radii. Okay, so the perimeter would be 100 divided by 360 degrees multiplied by the circumference, 2 times pi times, well, the radius is 5, so I substitute 5. This is the arc length, right? But it's not enough. Now I have to add the radius twice. So plus radius, this radius, and this radius. So I add it here. So it's going to be the arc length here, right, and radius and radius. So if I add these all, I'm going to find the perimeter. Okay? So obviously, this bit is going to be 10, right? So I'm going to add 10 to whatever I find here. So it's going to be 8.726 and so on for the arc length plus 10, which would be 18.726 something. Well, of course, you can write the full sentence into your calculator and end up with this number directly, right? And then if you'd like to round this, if the question says rounded to 3 significant figures, for example, you cut it from here, so it's going to be 18.7 centimeters for the perimeter of this sector. When it comes to the area, it is similar, right? So if you want to work out the area of this sector, right, this is the radius, this is the angle given. I'm going to use the same fraction, which would be 54 over 360, right? And then I'm going to use the area formula for the circle. So it's going to be pi times 7.2 squared. This was the area, right? Pi r squared. So instead of r, I write the given value for r, the radius. So it's going to be 54 over 360 multiplied by pi 7.2 squared, right? And if I calculate this, I end up with 24.429 and so on. And if I want to round this to 3 significant figures, then I cut from here and get an approximate value of 24.4. Because this is 2, I can just scrap this bit. So this is 24.4 centimeter squared. So this is how you find the area of the sector. You just use the same idea, a comparison of the given angle to the whole circle, so 54 over 360, that gives me this slice, all right? So if I use the area formula with this, I end up with the area of the sector, which is the shaded region, right? Now is your turn. Please solve these questions on your book and submit your answers online to see whether your answers are correct or not. Thanks for watching.